This how-to video covers the titration calculations practice problems that accompany lesson 7.7 of the equilibrium acids and bases unit. I will get you started on the problems, but it is up to you to calculate the final answer. Please include appropriate units and use scientific notation for numbers with more than 2 leading zeros. All right, so here we have the first problem. I want you to, trying to find my highlighter, there we go. Notice that you have to show all of your work for all calculated values and make sure you include units, as I've already said. You have already done problems like this where you had to find the products of an acid-base reaction. Remember, the key thing here is to notice how many acidic hydrogens you have and how many hydroxides you have. So for the first one, we have a 1-to-1 relationship, so that's pretty easy. For the next one, we have 2 hydroxides and only 1 acidic hydrogen. So I'm going to let you figure out what the products would be. All right, the next one is an actual titration calculation. It says if it takes 54 milliliters of 0.1 molar sodium hydroxide to neutralize 125 milliliters of an HCl solution, what is the molarity of the HCl? So this is a really straightforward M1V1 is equal to M2V2. I don't know why my hand's being so weird today. So you're just going to identify what your different values are. So there's a volume. So let's just make that one V1. Make this one M1 because that's the one that goes with V1. There's V2. And we're looking for M2. So you plug in the numbers and solve for M2. And you should end up with a number that is less than 0.1. The questions 3 and 4 are very similar. It's just a matter of identifying which volumes go with which molarity and then plugging them into the M1V1 is equal to M2V2 equation. So for number 3, you should get a molarity that again is about 0.1. And then for number 4, you should get a pretty small number. It's in the order of a thousandths place. You don't have to write it in scientific notation, but if you want to, that would be okay. All right, so next one is just a written answer. Wants to know if you can titrate a solution of unknown concentration with another solution of unknown concentration and still get a meaningful answer. So this is to kind of find out if you understand what the point behind your titration is. Notice it says explain your answer in a few sentences. Don't just say no. Don't just have 2 or 3 words. I want sentences. Explain yourself. Explain your reasoning. And try to write neatly. Some of your handwriting is making me question whether I need to get my glasses updated. All right, so then we got another example. So consider the following reaction equations. So we got the reaction between lithium hydroxide and sulfuric acid. Wants to know how many moles of lithium hydroxide are needed to exactly neutralize 2 moles of sulfuric acid. So this is just a mole-mole thing. It doesn't have anything to do with titrations or solution chemistry. It's just stoichiometry. So remember, this is where we do this is a 2x, and the sulfuric acid is a 1x. And your work can consist of just setting up your x's, and then for this one we have 2 moles of sulfuric acid. So you would write 2 moles there. So how many moles of lithium hydroxide would you need? So hopefully that won't be too much of a challenge. And then number 7 is the same reaction equation, same stoichiometry approach. And it says, well, how many moles of sulfuric acid are needed to neutralize 5 moles of lithium hydroxide? And so in this case, I'm going to change colors. We have 0.5 moles. And it wants to know how many moles of sulfuric acid it would be. Not too hard. Got a lot of white space there. All right, number 8, it says write a balanced reaction equation for the reaction between calcium hydroxide and nitric acid. So this is pretty much like the earlier questions. So we got some number of calcium hydroxide. And then some number of nitric acid. You still need to finish off the products. Notice that you're going to have a coefficient of 2 right here because we need to have 2 acidic hydrogens to cancel out the 2 hydroxides. All right, so question number 9, it says if it takes 50 milliliters of 0.5 molar calcium hydroxide solution to do the neutralization, what is the concentration of the nitric acid solution? Now there's a couple of different ways to go about doing this. I'm going to take a little bit more roundabout way to start with. So we're starting out, let's figure out how many moles we have of the calcium hydroxide, because we know that we can use, once we have moles of calcium hydroxide, we can figure out how many moles of nitric acid that we need. The other thing I want to mention is that milliliters times molarity gives you millimoles. And this is a really convenient unit because it allows you to not have to write a whole bunch of stuff in scientific notation. All right, so we have 50 milliliters of 0.5 molar calcium hydroxide. We do the math. Got my answers off to the side here. And we end up with 25 millimoles. Of calcium hydroxide. So this is going to be 25 millimoles, which means we need 50 millimoles of nitric acid. So now we're going to write this down here, and I'm going to change my color. So we have 50 millimoles is equal to 125 milliliters. So your volumes have to be in milliliters. That way the millis all cancel out. Times the molarity of the acid. I'm just going to put an MA on there. So then you do 50 millimoles divided by 125, and that will give you the answer. Remember that the unit for molarity is capital M. Make sure you make your M's pointy. If they're round, they look like lowercase m with M's, which is molality, if we're talking about solutions, or meters if we're talking about anything else. All right, so 10 wants to know how many milliliters of 0.5 molar nitric acid are necessary to titrate that much of the calcium hydroxide. So now we're solving for volume. Other than that, it's pretty much the same thing. So you find your millimoles of the base, which is equal to 25 milliliters times 0.05 molar calcium hydroxide. And then you have the number up here that goes with this. So you're just going to multiply that by 2 to get how many millimoles of acid you would need, and then you solve for the volume of the acid that you would need. And then the last one is a very similar problem, and this is where I'm going to show you the sort of a shortcut. So instead of finding millimoles of the acid and the base separately, you can combine that into that titration equation, the magic equation as I call it, in that you say that the number of acidic hydrogens that you have times the molarity of the acid times the volume of the acid is equal to the number of hydroxides that you have on the base times the molarity of the base times the volume of the base. So go ahead and we will set some of this up. Make sure I get the right color. So we're looking for volume of the acid. Here's our molarity of the acid. We only have one acidic proton, so this is going to be 1. And then over here we have the base. So we got volume of the base. And we have the molarity of the base. And notice we have 2 hydroxides. So I'm going to put a 2 there. So it ends up being 1 times 0.2 molar times the volume of the acid is equal to 2 times the molarity of the base, which is also 0.2, times the volume of the base, which is 25 milliliters. So there's not a whole lot to figure out with this, actually, now that I've written it out. So these guys will cancel, because the same term on opposite sides of the equal sign. And so you should be able to get the answer pretty quickly. All right, so that's it for this how-to video. Thanks for listening.